So in this problem, we're asked to deduce the rate law given changes in concentration over time. So we're given the description of a reaction, and then we're given a table that contains time and concentration data. And unsurprisingly, what we see is as time progresses, our reactant gets consumed. We're then asked to calculate the rate law, which really just means figure out the order with respect to each reactant. There's only one reactant in this case. And then also to calculate the value of the rate constant. So what we're going to do here is we're going to use the rules that we know about integrated rate laws to figure out what the order is with respect to the H2CO3. So I'm going to show you how to set this up in the calculator, and then I'm going to show you how to solve this using slopes. So what I'm going to do first of all is I'm going to set up a stat plot with my table in there. So I'm going to go stat, and then I'm going to select number 1, which is edit. And in list 1, I'm going to put all of my time data. So 0, 0.1, 0.2, 0.3 and 0.4. And then I'm going to go over to list 2 and I'm going to put my concentration data. So 0.4, 0.239, 0.143, 0.0854, 0.0511. Excellent. All right, and then what I want to calculate in list 3 is the log of the concentration. So I want to calculate the natural logarithm of what's in list 2. So I go up to the title row of the list, and then I just go ln, and then I go second function list 2. Now close the parentheses, and what's nice about this is it auto-fills everything. And then I go over to list 4, and I want to put in here 1 on the concentration. So that's going to be, so I'm in the title row here, 1 divide, and again it's my values for concentration, which are in list 2, and you can see it auto-populates those lists. So I don't have to do very much math at all. So what I'm going to do now is I'm going to go back into stat, and now I'm actually going to do a calculation. And the type of calculation I'm going to do is called a linear regression. So I hit number 4, and what I have to do is say what my list is. So my X list is going to be my time, which is list 1, and then I'm going to check first order first, which is the log values, right? Because log of the concentration against time will be linear if it is first order. So I need list 3 in here, which is the one that has those things. So that has the log of the concentration. So now I go down to calculate and I hit enter, and it does it for me. And the number that I'm going to pay attention to is this r squared. And if that is very, very close to 1, that's telling me that those x's against those y's is a straight line. And it is, right? So you can see here that the r squared is very, very close to 1. So that tells me that a plot of log of the concentration against time is linear. So that means I know that this reaction is first order. So I know what my rate law is going to be now. So let's go back here. My rate law, it's just going to be first order with respect to the concentration of my reactant. Now, the next bit is I have to figure out now is what is my rate constant? Well, my rate constant is the negative of my slope. So that's just going to be 5.14. Okay, 5.14, there it is. It asked me to round my answer to 2 significant figures, so it's just going to be 5.1. And then it says make sure it has correct units, and we know for first order that the correct units are going to be time to the minus 1. And in our case, our time's in seconds, so our units are going to be seconds to the minus 1. So this is just going to be 5.1 seconds to the minus 1. 5.1 seconds to the minus 1. So that's probably the easiest way of solving that type of problem. Now, if it wasn't first order, if this r squared wasn't near 1, what I would then do is check that it's second order. So what I would do is go into the stat menu. I want to calculate again, so I go over. I still want to do a linear regression, but what I'm going to check this time is I'm going to check not for time against the log of the concentration, but this time I want time against 1 on the concentration. So that would be list 4 in my table. So I go into list 4, again I go down to calculate, and what you can see when I press enter is that my r squared is a lot further away from 1, right? 0.92. So it is not second order. If I go in here and I go over to calculate, number 4 I can check first order. So list 1 is still time. List 2, my y's this time should be list 2, which is where I had my concentrations. And then I calculate, and again you'll see that my r squared is a long way from 1. So I know that it's not 0 order. Now I want to give you a little bit of a warning about this is before you can use the linear regression and actually get the r squared, you do have to set one thing up. So what you want to do is you want to go second function and then go into the catalog and then hit D. And so if you look here it is, there's D, and it'll go down and then scroll down a little bit until you get to diagnostic on, and then hit enter twice and turn the diagnostic on, and then the linear regression will behave like it was for me. Okay, so that's probably the quickest way is to set up the stat table and then use linear regression to figure out the reaction order.